Okay, we're in section 21 of the notes now. We're going to do the lecture. A little preamble here. I want to point out a lot of students don't like word problems. All right. And I'm going to say that for the most part, words are really important. The language is really important. And unfortunately, what happens to a lot of students, they go into STEM field thinking that it doesn't require any reading whatsoever. And they're really missing the point. To be well educated, you're going to have to read and make some attempt to understand what you're reading. Now, I'm going to say for the most part, the word problems that we give you, they're not long passages, right? Some of the more challenging word problems, though, can be quite detailed in their words, all right? So I'm going to say over here is that for the most part, we're not really dealing with terribly difficult problems. However, rest assured that other people have trouble with word problems. You're not alone, all right? Everyone's got trouble with it, all right? So what I'm going to claim over here is that we're going to be given problems that are reasonable in nature. They're related to calculus, though. However, if you do not have the skill set that you acquired in prior courses or should have acquired in prior courses, it's going to be tough. Now, granted, there are many great word problems out there. I mean, there's books filled with them about word problems. Interesting ones, by the way, not the dull ones, interesting ones. I present, two here. And the reason I do that is I'm going to say number one, historically, it's a high school or middle school level word problem, but Einstein was given this problem. He got tricked by it. All right. Now, someone says, do people like getting tricked? Not really, but for the most part, it's entertaining, right? It's like watching a magician. Sometimes they trick you. All right. Word problems are tricky sometimes. You might be deceived. You might know how to do it. If you keep giving up, though, like say, I can't do a word problem, you'll never be able to do a word problem. It's pretty simple. Now, granted, here's another example. It's not a word problem, but an example of a problem that, you typically give students at the 119 level that have trouble with it. There's no doubt about it. But again, I'm going to say it's not a bad problem to do. You can do it. Both of these problems are not beyond your skill set. Are they related to calculus? No. Are they related to the stuff you had prior? Of course they are. One's a word problem. One's a simultaneous nonlinear system. Stuff that you've dealt with in the past. All right. So what I'm going to claim over here is what we're really kind of do is we're trying to get to what's called the related rate word problem, which is related to what we've just covered with implicit differentiation. But now we're going to differentiate with respect to time. And again, I'll go through this on the whiteboard later. But the bottom line is it's so important that you start to read. As you read, there's a good chance your understanding will improve. Again, if you're entering the STEM career thinking you don't have to read, you're not going to get far in a STEM-related career. Reading's important. Reading, writing, arithmetic is important. We'll go through this example over here, and then what we'll do is we'll talk about the examples after that. All right? These are related rate word problems. We go to the whiteboard. Give me a second to get there. All right, got the whiteboard. Okay, so first page, relatively simple, basically just telling you, get busy in the reading department. I really mean that. Get busy in the reading department. I do give one anecdote over here about a colleague, very bright colleague. She's no longer at the school though, but a bright woman in the math department at Essex College, excellent command of the English language. I seek her advice on many occasions, at least in the past I did. Well respected at Essex County College and other places. And she's really good at, writing things down. She's really good at it. Really fast reader, very fast writer, bright, no problems at all. But I'll be honest with you, she got stumped by what I thought was a simple word problem. All right. Why is that? I don't know. Maybe she choked up on it. It happens sometimes. I choke up on simple things too, by the way, and I miss meaning. And by the way, I've done it in front of students before too. I can remember when I first started teaching, it was at Rutgers, New Brunswick. I remember I was at the board and students said, could you do this problem? And I looked at it, I said, yeah, sure. It's got to be simple. And I got stumped. Right? It happens all the time. Someone says, why do people get stumped with things? One is they're not actively engaged in it. You might be surprised to hear that. Like a teacher may not be actively engaged in what they're teaching. They're not doing problems, by the way. They may know what to say, but they're not actively engaged doing a lot of problems. They're just not doing it. You guys should be actively doing problems all the time, by the way. Actively, working all the time, trying to improve your skill set. All right. I give some examples over here. Again, I know I talked about this prior to opening up this page over here, but number two is not a word problem, but it's a problem that students find difficult. But number one was given to Albert Einstein. He got stumped on it. He felt kind of foolish, I guess, after being stumped on, like a middle school, high school problem. And here's a guy with a PhD, Nobel Prize, working at Princeton University, got stumped on a simple problem. I got to be honest with you. I think it does. He certainly was an achiever, but I think later in life, it's not so much of achievement. He became more of an entertainer, right? Although he was entertained by things, I don't think he was really actively pursuing things anymore. He made his mark early in his life, which is great. And I'm not going to say he coasted throughout his life. He was certainly a bright man. I'm sure he worked very hard, but people get stumped because they're not actively in pursuit of getting good at something anymore. All right. So I'm going to claim that you can look at those two problems if you want, think about it, but we need to cut to the chase. And the chase is going to be this. We're going to be what's now doing related rate word problems. All right, let me go through this with you. Number one thing that you need to do is read the problem. They're generally incredibly simple stories. So read. I can't say enough times. Reading is perhaps the most fundamental activity in any academic environment, including the one that you're chosen, which I believe for most students is STEM related. You need to understand what you've read. That's a struggle that's going to last you the rest of your life. I still struggle understanding what I'm reading. It takes time, it takes effort. Sometimes I give up. I say it's not worth understanding what they're talking about. I move on. I particularly do it with newspaper articles. Sometimes I'm reading it, I get tired. I don't want to deal with it anymore. I go to the next article. Happens, all right? These readings are going to be incredibly short. I notice sometimes with newspaper articles, they could go on easily 60 minutes of reading for an article, particularly in some of the articles that you see like in the New Yorker or something. They're really long, all right? These problems are not going to be long, by the way. You can read them in probably under 60 seconds. I'm going to claim that you should visualize what you've read. In other words, make a sketch of what you read. You should be labeling your sketch, what you're seeing. Now, when I say labeling it for you, no one else. It's for you to look at your sketch. You want to know what the relationships are. You want to know those relationships. You need to label those things. For example, if you're talking about the surface area of a cube, it would be a good idea to write down the algebraic relationship of the cube surface. Maybe even draw a cube so you convince yourself you know what the surface area is. Variables, things that change, should clearly be understood at this stage. Some things will be changing, all right? Write down any derivatives that have been given to you and any derivatives that have been wanted. These are going to be related rates. What I mean by related rates, these are typically going to be problems where the derivative will be related to time and we'll be doing it implicitly. So I'm going to say these are going to be rate problems with respect to t. Here's the deal. After we do all that preliminary work, we're just going to plug in and solve for the unknown. So let's take a look at an example. And this is an example I'm going to look at. There's a provided picture. Granted, you may not be able to get to the end of this, but the bottom line, I'm looking at it, says find the rate of change of the distance between the origin and a point on the graph, y equals x squared plus 1. I definitely see the parabola, the person who put the picture down. I see the visualization. I'm going to tell you, they say dx dt. I'll write this over here for you. Dx dt is equal to 2. And there's a unit on that, by the way, and that's centimeters per second. Now, this is where a lot of students, they drop all things now, and they say, they announce to the world they can't do it. Well, Go back and reread it. You don't even know what the question is at this point. But the bottom line is, let's say, find the rate of change of the distance. So I'm going to say what they're asking for, dd, rate of change of the distance with respect to time. At least another question. Find the rate of change of the distance between the origin and a moving point on the graph. I'm going to say there's a point in the graph that's moving. Now, what do I know about the moving point in the graph? I know the x is changing at a rate of 2 centimeters per second. So this point is moving in that direction because 2 centimeters per second is positive. But if they're talking about now the distance is changing, right? dt, right? At some point in time. Let's write this down. At what point in time? At the point where the point gets to be 1.1, 2.21. That's their question. Here's my problem. I know these relates are related. I just don't know what the relationship is. So what I'm going to do, I'm going to blow this up. I'm going to look at the story with D, and I want to say this relates back to prior knowledge. The origin is 0, 0. And what's this point over here? Well, it's x, comma. Well, I hope you remember that this is a function, and that function is x squared plus 1. So now I'm going to write down the distance formula. And what's distance going to be equal to? Well, I'm going to write down distance squared is equal to the change in y's. That's going to be x squared plus 1 minus 0 quantity squared plus the change in x's, which is x minus 0 squared. The distance is going to be the root. Let me simplify this. This is going to be x squared plus 1 squared plus x squared. What do I need to do? I need to get a relationship now between dd, dt, and dx dt. I'm going to differentiate both sides now. So the derivative of d with respect to t is going to be, let's write this down. It's going to be 1 over 2 times the root x squared plus 1 squared plus x squared. Now what I got to do, I got to do the derivative of the inside. Let's put that down. And I'm not saying it's easy. I think I can do it though. It's going to be 2 x squared plus 1 to the first power times 2x plus 2x dx dt. Again, I hope I'm not going too fast here. dd dt is, I'm going to clean this up a little tiny bit, by the way. I'm going to divide through by 2. And what are you going to get? I'm also going to factor out a 2x. And then what do you get? I canceled the 2. Oh, no, I'm sorry. I can't factor out 2x. I'm sorry. I'm going way too fast for my own good. I canceled the 2. I'm going to factor out an x. So you get, let's see, I cancel the 2. So I get x squared plus 1. Factor an x, there's a 2 there, so times 2, and then plus, I can't, plus x, right? No, plus 1. Let me make sure that's true. You get 2x, x squared plus 1, and x. Yep, I did all right. Someone says, I don't even know what you're going to do now. I'm going to answer the question. Someone said, what's the question? What's dd dt at that point? What point? 1.1, 2.21. Pop it in. What's x? 1.1. Yes, I know this is difficult for a lot of students to do. 2, 1.1 squared is going to be 1.21 plus 1 plus 1. I'm just plugging in, by the way. What do you get on bottom? It's crazy. It's difficult. What do you get? 1.21 plus 1 squared plus, I got to do it again, right? 1.21. What's dx dt? Well, if you can't remember, it's written down. It's 2. Now, by the way, I know it's 2 centimeters, okay? But anyway, I got to do the arithmetic here. And I'll be honest with you, I don't know if I want to do the arithmetic. I think it's best left to a calculator. I want to look at the next page, though, and that's where all the work is going to be. And I want to see if I got that. You know what I'm going to do? I'm going to work through the arithmetic for you. It's tough. I know that. And you know what I'm going to do? I'm a little tired right now. I'm going to go to Sage. I hope you have this written down. And this screen will disappear. And I'm going to open up another screen. But I have the screen in front of me. It's like having a piece of paper in front of me. Just like you should have paper in front of you. You should be copying things down. And, you know, certainly that's a skill you also want to acquire in your educational process. All right. So I'm going to just do, let's see. I'm going to launch my, let me share a new screen with you. Give me a second. Yeah, I'm sharing the right screen with you. Sorry about that. I'm going to open up Sage. Oops, sorry about that. Now, again, what I'm claiming over here is you probably should take notes. I'm looking at my notebook. That's it's actually my iPad, by the way. I'm writing on an iPad. And I'm going to do the computation. 1.1 times, whoops, sorry about that, times 2 times 1.21 plus 1. Getting tired, right? Plus 1 star 2 divide by the square root, SQRT. Ooh, this is going to be a tough one. 1.21 plus 1 squared plus 1.21. I'm just copying what I'm seeing in my notes, by the way. What do you get over there? You get that number there. Now, someone says, is that the number they got? Well, look at it. What they get? 4.83022. We did okay. All right. Now, someone said, well, you didn't do all the arithmetic. You're right about that. Let me go back to my notes. And the only reason I go over Sage with you, not that I want you to use Sage. I would love for you to use a computer algebra system, but our goal is for you to become comfortable with other tools you're using, including if you just simply say, I want to do that by hand arithmetic. But let me point out what I found. And I found the answer over here. And I'll tell you what, when I did this computation, I gotta get my pen back. When I did this computation here on Sage, remember I just typed that into Sage. What did I find? Let me go to the next page and show you what I found. I found this number over here. All right. What's the unit on that? A little precise, but let me write down. It's 4.83 centimeters per second. All right. The answer is over there. Okay. We're at the interface now. This is the interface we face all year long. I should say all semester long. We give lecture. We hope you're paying attention. After lecture, we go through examples. After we do lecture and examples, you're supposed to study that material and then do homework. What's homework? Homework is basically, it's still a study department, but also working problems that we give you to work. Make sure you can do that. You know, whether it's these handwritten problems or WebAssign, you got to get busy with the trying department. Thank you.